Hello, in this video we're gonna see how we should solve this strange looking integral. So let me start off by reminding you that dx here is the same thing as h, where h is the limit as h approaches 0 of f of x plus h minus f of x over h. In other words, dx is a very small change in x, and it's infinitely small and we can treat it as a limit. So if I multiply this integral by dx and divide it again by dx, I'm going to be left with this expression. Let us examine it here. Sine to the power of dx x minus 1 over dx. I told you that I can treat dx as h, and thus I can write it as limit as h approaches 0 of sine to the power of h x minus 1 over h. What if I now plug in 0 for it? It's going to be sine to the power of 0x minus 1 over 0, which is 1 minus 1 over 0, which is 0 over 0. Thus, we can conclude that it is in indeterminate form, and we can use L'Hopital rule. So, how should we use L'Hopital rule? We were going to differentiate both numerator and denominator. Thus, it's going to be, it's going to be sine x to the power of h ln of sine x, because it's exponential, over 1. And if we plug in h equals to 0 now, we're going to get ln of sine x. Thus the limit as h approaches 0 of sine x dx minus 1 over dx is ln of sine x. And I can now plug it in here, and my integral would be the integral from 0 to pi over 2 of ln of sine x dx. The interesting thing about this integral, it's equal to the same thing, 0 to pi over 2, as ln of cosine x dx. And if I add these two together, 2i, it's going to be 0 to pi over 2 ln of sine x plus ln of cosine x dx. I can use the property of logarithms, and it's going to be ln of sine x cosine x dx. And if I use the trig identities here, it's going to be 0 to pi over 2 of ln of half sine 2x. I can use the logarithm property here again, 0 to pi over 2 ln of half plus ln of 2x, ln of sine 2x dx, 0 to pi over 2. So if you calculate this integral, it's going to be negative pi over 2 ln 2, it's not hard to see, plus the integral from 0 to pi over 2 ln of sine 2x dx. This is equal to 2y. Now, right here, I'm going to focus on this integral here. I'm going to call this I naught, which is the integral from 0 to pi over 2 of ln of sine 2x dx, and I'm going to multiply and divide it by 2. You'll see why. I'm going to say that u equals 2x, thus du equals 2 dx, and dx equals 2 du over 2. I naught, therefore, is the integral from 0 to pi over 2 of 0 to pi, if I change the bounds, of half the integral from 0 to pi of ln of sine u du. So by this definition, we can say definitely that the integral from 0 to pi over 2 of ln of sine 2x dx is half the integral from 0 to pi of ln of sine u du. And for this matter, so this integral here is equal to our initial integral. Sorry, this integral, yeah, it's equal to our initial integral, and this has a property that this integral is actually the same integral. Now I can multiply it, so this is 2i, our initial integral, multiplied by 2i. These are going to go away, thus this integral from 0 to pi over 2 ln of sine 2x dx, let me write it a bit better here, the integral from 0 to pi over 2 ln of sine 2x dx is I, our initial integral. And I can write it as my 2i as negative pi over 2 ln 2 plus I, and my integral is going to be negative pi over 2 ln 2. Wow, it's a very neat result, and if I can write my final result of the integral of 0 to pi over 2 of sine to the dx x minus 1 to be equal to negative pi over 2 ln 2. And I bet you've never seen an integral like this, but this was really interesting to solve. Thank you for watching this video. Please like and subscribe, and I'll see you next video.